Hello and welcome to another episode of Invalid Entry. My name's James Taylor and we're here on the 14th of December. I can't believe that we're on the 14th already and I've done 14 Invalid Entry videos. It also means that I've done, at the moment, 13 videos from the other channel, which is absolutely amazing. Today we're going to start work on a little side project. I'm trying to interleave these videos so we don't get too into just snow or too into fractals or whatever. And today what we're going to do is we're going to look at a little thing which is natural language processing. And the reason I'm building this natural language processing is because I'm really interested in building some kind of Santa. I did click the button right. A Santa helper, a naughty nice list thing based upon your Twitter feed. So the idea is that you put someone's username in and it tells you whether that person has been naughty or nice. It's a bit of fun. It's quite an interesting little project. Loads of little libraries. We're going to make it a bit scripty, a bit hacky to begin with. And then I think maybe we'll turn it into like a Discord bot or some kind of stream thing. I don't know yet. But the point is, I want to know how hard this was going to be. I originally was going to do this as like a line-by-line programming thing. And then I realized it's actually quite a little bit more complex. And then it's got a load of underpinning things. So I'd probably do it in the new year as a full-length video. So I'm just going to give you a very quick run through now. So basically, at the moment, it breaks down to two parts. The first part is getting access to Twitter. So I have an app. I've stored my credentials in a separate file so you can't grab them. You can't see them on the screen. Basically, I open up the API. I then make an API just to make sure it works. So I'm calling who is this person, J1's. Got their real name come out. Oh, look, it's me. And then basically what I can do is I can then call the recent on any user I like. So I've been playing around with another user, one of my friends who does a lot of tweets, J1's, and there is my recent tweets that I've been making. So you can see all kinds of links and things showing up. Now, I don't want to do all the analysis myself. There are toolkits out there which will do natural language processing, and we can do something called sentiment analysis to work out whether or not these are positive or negative tweets as defined by the people. So first of all, there's a thing called Nltk. It's worth installing. You can pip install it. Once you install Nltk, after you install it once, you need to download the content that makes it work. And Nltk basically uses AI, and you build a model which allows it then to, based on probability, for it to analyze sentences. But it has some really cool functionality for analyzing sentences. So basically, you install this by just doing nltk.download. Once you've done it once, you don't need to do it again. It doesn't need to be part of the application going forwards. Whole bunch of imports, lots of imports here, including some frequent distribution samples things. Now, one of the things that comes with Nltk when you install your Twitter samples package is actually some positive and negative tweets. So other people have gone out there and there's 5,000 tweets that have a positive vibe and 5,000 tweets that have a negative connotation to them. What we can then do is we then use a tokenizer. Now, there's two tokenizers in Nltk which are really powerful. There's actually lots of them. One is the sentence tokenizer and one is a word tokenizer. So you can use the sentence tokenizer to break down paragraphs into sentences that you can then parse and work out whether, positive, negative, or whatever you want to parse in that. And the word tokenizer breaks down a sentence or a lot of sentences into individual words. So you end up with my tweet that I've pulled back my target tweets at this point, and it breaks it down to words. And what it also does, if you actually use the this pos tag thing, it basically works out what each word is. So it says, oh, this is a verb, or this is a noun, this is a verb, and so on. So basically, the VB means it's a verb, and then the other letters in the end change, like the tense of the verb or things like that. So it basically understands all the different types of words, and there's a big long list of those are. So proper noun, noun. So NN is always noun, but NNP is a proper noun. It's but a common noun. There's actually a long list of these from here, which you can go and look up. So basically the different classifications of words. Then it gets really interesting is basically because some of these words you don't want to ignore, and there's a couple of functions I grabbed offline to lemmatize the words. And also, this basically changes the sentence. So I'm just going to run this again for my function. Did that run? Yes, it did. So this is my sentence. So the first sentence was before we lemmatized it, and the second sentence afterwards. So it might seem very similar, all the words are the same, but it's changed the word was to be. So it's basically standardizing the words into, I guess, current tense rather than past tense, just so we can work out the meanings of the word. So the sentence now doesn't look like just like that. Kev, be very kind this evening to show me his curses, Santa, COD, because it obviously thinks coding turns into COD. And what I learn be. So it said learnt, it's changed from learnt into learn. was back to B again. Also that I need to work harder on my audio level. It's removed the pluralization. So anything that's plural, it's supposed to singular to help understand what the meaning of the word is. Now it knows it was plural and it knows what the root word is. So it helps you establish what the root word is. It also means you can then change sentences if you want to future or past by running it through this Nltk. So I now want that sentence to be a future tense. Really quite cool. The other thing I found online which was really cool was this thing, remove noise. So especially if you go analyze Twitter sentence, you want to remove noise, you want to remove anything with @ symbols on, you want to remove any URLs, because URLs just basically don't work. Like, because URLs, here's a URL in there, and it just breaks the URL. So this is going to remove URLs. So if you run that, and you remove noise, it basically strips out a whole bunch of stuff, which is nice. It left a URL in there, interestingly. And also there's a word called stop words, which comes from Nltk as well. So then we have now is that be careful, kind evening, show courteous ante. It's taking out all the words which basically are just cluttered. They're neither positive or negative. They're just cluttering up the sentence for analysis words. They matter importantly for English, but they are cluttering up the sentence when you try analyze it. What we can now do is we can do the same with the positive and negative tweet tokens to end up with these arrays of positive and negative words. Again, I took this from a tutorial on how to do it, and I will put that link in the description below. Very powerful link. And basically running through that tutorial a bit more, you basically end up producing a frequency distribution of words in the positive word list and a frequency distribution of words in the negative word list. So if you've got this, basically of the 5,000 tweets that were positive, 3,691, or the 3,691 occurrences of smiley faces. So smiley faces is a really, ASCII art, is a really strong indicator that it's a positive tweet. Similarly, you can then say, well, this many appears in the negative tweet, it's a really strong indicator of negative tweet. Whereas things like ... weirdly, if ... appears, it's 290 of those tweets had ... in, so that's an indicator it's positive. They may appear in negative tweets as well, and it's just working out that ratio of all these different words. We actually don't use the frequency distribution. We actually do is build a model. So we actually build this model, and this is where it gets a little bit complicated, and I realize it'll go much more than a 10-minute video, is you actually build the model up, and you end up building a minor model. It doesn't take very long to run, of a model of what may or may appear in sentences. We can now run our tweet against this and say, does our tweet, after you remove noise from it, is it a positive or negative tweet? And it says this one is a positive tweet, which is great, because I was saying thank you to Kevin. And what we can actually do now is actually run it for all the tweets in my thing, and you get back a list of positive or negativity of my individual tweets. We can now add these up and say, well, I've got 1, 2, 3, 4 positives and 1, 2, 3, 4 negatives. So I've been 50% nice in the last 10 tweets at least. I'll say this year, last 10 tweets. I am aware that 4 plus 4 equals 8. So I am interested as to why there's only 8 tweets there rather than 10. But we'll have to look into a bit more detail on the loop and actually what the data I got back up here was. Did I get 10 tweets? Did I get 8 tweets? Not sure exactly. We'll have to count them up. Anyway, basically that is it in a nutshell. Now this code can be cleaned up an awful lot, and the big problem I had with it was it generates this classifier here, this model here, takes it a little bit of time to generate, not a long time, but I don't really want to do that on every single loop. So if we do build a classifier, I'm going to put my classifier at the start of my script before I start analyzing tweets. The code to actually, once it's built though, we can use it on other people. So we can basically go up to the top, we can just all the way to the top, and we can pick another username here. If I go to Twitter, let's see who is tweeting on Twitter today. It's Ben Francis. Here we go. Ben is an old school friend of mine. Worked at Mozilla for a bit, so we can drop him in here. There, Ben Francis, you see. Might still work at Ben Francis. Those look like my tweets because I didn't put his username there. Yep. There you go. Oh, Google had an outage this morning, which was quite amusing, which is why I think he's saying and it's back. So if we go right down to the bottom where we measure his tweets, what we now can run that, and you can see Ben is a really positive guy, and he actually is a positive guy. 1, 2, 3, 4, 5 positive tweets to 2 negative tweets, and you can also guess if I look back, that one is probably going to be it's probably going to be if I actually print the tweet off here, it's probably him saying he can't do my work, Google fell over. There you go, that's a negative tweet. And so yeah, it works really nice. So I think it's a really interesting little gimmick for you to say whether something's positive, bad, negative. Now, it all does depend on those 5,000 tweets that we imported, those 10,000 tweets that we imported. If you wanted to get better accuracy, you should take a much larger sample. It's probably also very biased towards English. I'm guessing that the processing is biased towards it. I'm guessing that those tweets are probably English tweets. So I do know if you put Chinese messages in, the word segmenter really struggles with it because there aren't any spaces. Each character is a word, but it's a bit more complicated than that. So you do need to be a bit careful about AI being biased towards your sample data. And if you are only an English speaker and you've only picked English tweets, or you've only done your positive, negative vibe based on English tweets, it's a very clear-cut sort of thing, you'll introduce bias by only having that sort of bias in there. Also, 5,000 messages, 5,000 short messages is not a large sample size in the grand scheme of things when you think of all the things that could or couldn't be positive, and sarcasm and things like that. So it's very hard to detect sarcasm. I suspect if I put my wife's in here, it would just say she's negative because she's generally just sarcastic, she's being positive. Actually, man, that's not true, because sometimes she says to me, yeah, that sounds like a good idea, when she really means it isn't. So just think that through when you build this. Anyway, that's all I've got time for, I think, in today. As I said, this is a massively complicated subject. I thought it would be nice and simple, but I wanted to put it out there because we're going to use it tomorrow in building a more cool function. I'm going to simplify this down now to a single function which takes a username, and we'll basically say, it will actually take some preset arguments to build an object. Say a single function takes a username and says X percentage nice. That's what we're going to do, and then we're going to build a nice animation or something from the back of that. Anyway, I'll see you guys tomorrow.